In this lecture, we will revisit the topic of generics by extending our previous discussion on polymorphism and typecasting. Let's see what the learning objectives are. So number one, we would like to consider a general collection, for example, array of any. So the any class here is analogous to the Java object class, simply at the top of the inheritance hierarchy. We want to see how the storage versus retrieval can be done when we have a general book. And then with contrast, we want to talk about, secondly, what would be the storage and retrieval like if we try to declare a generic collection, in this case array of G, and then G is simply a class level generic parameter to really represent the type of each member in the array. So we want to see really item number one versus item number two. So finally, we'll also make some concluding remark to talk about generics versus inheritance being two independent design aspects that you want to pay attention to. We'll give you some guiding principle at the end of the lecture. Okay, so let's talk about some motivating example. So let's consider a simple class called book. You can think about the book is somehow similar to the birthday book that we have discussed all along. And let's say we got names, simply an array of string. Notice that the book over here is not generic, right? That's the intention. We want to talk about just a very general records that's stored in the book. You can see the records over here is going to be array of any, similar to array of objects in Java. And now we want to create an empty book. So here I'm omitting all the implementation details or any contracts. You can definitely fill it in if you wish for your practice. So we got constructor here, and then we got one command. So you can see the type of string for the name and also the record for any. So now I want you to recall right away about our discussion of polymorphic feature arguments. Okay, think about what the consequence would be when we actually declare the parameter type over here simply as any. What can we pass as arguments? So that's the question. And then we got another query over here, and now you can see the return value here is any. Given that we're storing anything, of course we can return anything. And also given that we're storing anything, of course we can store anything inside the book. Okay, so these are the two most important types that you have to pay attention to in order to understand in general how the storage versus retrieval are actually manipulated for general book. Okay, so now here is my question to you. I want you to consider the following fragment of code with line number and tell me which line or which lines you believe is not going to compile, meaning that it has a type error. Okay, so now line number one, we simply declare birthday and also phone number to be of some static type. And now line number two, we declare book and also it's Wednesday. So this boolean here is going to evaluate to true if the particular dates we are talking about is a Wednesday. Otherwise, it's not a Wednesday. Okay, so line number three, we simply create a new book. Over here, you can see the dynamic type is simply the same as a static type. Apparently, that's going to be valid. Okay, line number four, we simply create a string objects, simply some phone number. And then, so now line number five, think about whether this line should compile, right? Think about polymorphic arguments that we spoke previously. So we simply add Suyang and then her phone number into the book. It's more like an address book. And then we create another birthday object over here, simply of type dates. And then simply 1975, April 10th. Okay, and then, so now we're adding a second record. So notice that line number 7 versus line number 5, right? In some way, we are adding two records of different types. You can see phone number is a string, and also birthday is a dates. Do they have a common ancestor? They do. However, it's just the any class, like an object class. So that means they don't really share anything in common except for the any, the implicit top class in the hierarchy. Okay, and then finally, we got line number 8. We say it's Wednesday. So we want to know if Yuna was actually born on a Wednesday. So what we do is we simply say b.get. So we are calling the get query over here. We want to get Yuna's birthday, provided that we store her birthday into the birthday book. And then we want to see that particular dates, whether it's a Wednesday. Okay, so now get day of the week. So now get day of the week, you can assume that, let's make the following assumption. Get day of the week is assumed to be a declared feature in the date class. That's something you can assume. All right. And then think about the value over here. 0 means 1 means Sunday, and 2 means Monday, and 3 means Tuesday, and 4 means Wednesday, and etc. Okay, so these are the 8 lines of code, and then the question is which line or which lines will actually contain a type error. Okay, pause the video and think about it before I go over the answer with you. Okay, so let's now go over the answer quickly. Let's go over line by line. The first line over here, this one should be valid because we're just declaring variables. And for the second line over here, it's also the decoration. And the third line, the dynamic type is simply just happen to be the same as the static type over here. So this is also fine. And you can see over here, this line here, similarly, we're also creating dynamic type being just the same as a static type. So that's also fine. And here, we're just assigning a string literal. That's also fine. So let's see the remaining lines. So this might be more worth our attention. So first of all, what about this line here? When we say b.add Xuyang and also phone number, in order for you to see whether this should be compiled, you should really look at the arguments, right, and the parameters. So we are really, for this line here, we are really using the add command over here. So Xuyang over here matches the string type, so that's not a problem. So now does phone number over here match the any, right? Remember callback value, right? That's what we said before. The callback value simply say, implicitly we're going to get record is simply assigned to the phone number, the arguments, the phone number. So now will this work? Well, of course, because phone number over here is simply just a string. Static type is simply a string. And then the record over here, the static type is declared to be any. So now we are really asking whether the string can fulfill all the expectations on any. Yes, it can, because string is simply a descending class of any, right? It's kind of the argument pattern that we discussed very thoroughly in the previous lecture. So this one here will compile. And with a similar arguments, you can also argue that b.add Yuna and also birthday also compiles. Very briefly, Yuna is a string, also matches. And also the birthday here is also a descending class of any, using callback value, the implicit callback value assignments. Okay, so line number 5 and line number 7 also is fine. What about line number 8? So that seems to be the only option left that's actually invalid, but we want to see why. Okay, so now first you want to see where exactly you got the compilation error. Okay, so this is exactly where you actually got the error. Just this orange expression I'm highlighting here. But let's see why. So over here we are actually calling the get query from the book class. So this is the get. And notice that the static type of the return value is simply just any, which means from the compiler's point of view, this expression over here statically is simply just any. So now, any manipulation you want to do on this particular return value here, from the compiler's point of view, you can only call the expectation on the any class on that. So now, is get day of week, is that a feature or an expectation on any? So that's a question you want to ask. Is this expected on the any class? The answer is no. Because remember what we said previously, this is assumed to be a feature that's expected on the date class. Okay, so no. It's expected on the dates. Or to be make it more general, it's actually expected on the dynamic type of this particular return value. But the static type, as far as the compiler is concerned, is actually of type any. Okay, so that's a very you can think about this more like a very quick review from the previous lecture about polymorphism and also polymorphic argument and polymorphic return value. So line number 8 will not compile. Okay, so that's the conclusion from this example here. So now let's see what we can do. Remember, we said before, for you as a developer, you find that the compiler is being very inflexible. So if you're really sure the return value is really, for example, in this case, I know that when I actually put Yuna's record inside, I really put her birthday over here. So I'm pretty sure the return value, assuming that the implementation is correct, must be dynamically a birthday. So now if I'm really sure, what can I do to really signal to the compiler? The answer is typecasting. So why don't we take a quick look? So recall that having polymorphic arguments, the consequence will be you can have polymorphic collection for the storage. Let's see again how this can happen. So after this line over here, what we're creating is an empty book. And I'm just going to trace how the records array is now going to be changed. That's what I'm going to do. Okay, so let's take a look. In the beginning, the records array is simply going to point to the beginning of an empty array, just in the beginning. So let's now take a look at the two lines of additions. The first one, b.add Suyang and the phone number. So here what we're doing is we're growing the array size, let's say index 1. So this one here is going to point to some record, right? And the records array, so now it's going to be a string for the phone number. So this will be a string objects. And then it will be whatever number it is. Okay, and then let's just make sure it's right. Well, it's not really crucial, but it's good to be precise. Okay, so that's the first one. And then what about the second one? For the second one there, it's now going to, second one here is going to add a second record into the array for the records. So now this one here, I'm going to say grow the size of the array by another. And now this is going to point to a birthday objects. So in that case, you can think about this is like a dates objects. And then we got these three fields. I'll just say 1975, 4, and also 10. Okay, you get the idea. So now this array is indeed polymorphic because, so now it's really important to know, when you got records at position 1 and also records at position 2. Okay, let's now fill in something to tell you the types of them precisely. When you talk about static type, and also when you talk about dynamic type, right? So that will be the static type for both of them. For both of them, since you declare the records to be array of any, so this will be the static type as we talked about before, right? So this will be simply just any. What about the dynamic type? So now for position number 2 is simply a dates. And for position number 1 is actually a string. You can see dynamically they are different. So you can see having the dynamic type being a descendant class of the static type and having the dynamic type being a descendant of the static type. So that's exactly what the polymorphic collection will look like. Okay, so now let's go back to what we want to do. We want to signal to the compiler when you actually return this expression over here, when you want to return b.get Yuna, so this one should really dynamically be a birthday, like a dates object. How can we do that? Well, we can do a cast. So what you would do is, let's review the cast syntax. You would say attached dates, and then b.get Yuna, any expression here that's going to be, you want to really check the instance of. And then if that's the cast will be successful, in that case it's going to be Yuna birthday, and then we'll do whatever we like over here, right, to check. So now this cast will succeed because think about the hierarchy over here. So we got any class at the top of the hierarchy, under which we got the string class, and also we have also the date class. So now think about what's happening over here. The static type right now is simply just any, right? So static type, and the dynamic type is actually the dates. So now can we cast into this particular dates object? So we can we cast into this? And we also discussed in the previous week's lecture about casting. So this will be okay because we're really asking whether the dates, the dynamic type, can really fulfill the expectation of the orange one, which is the cast type. Can it? Yes, it can. So now the cast will be successful. So now the Yuna birthday over here, Yuna b-day over here. So this one has the static type of exactly the cast type, which is dates. Okay, you want to see beyond the syntax of the language over here, right? So if you do in other OOP, like in Java or C#, any language that supports OOP, so you will do something very similar. Just the syntax might be a little bit different. Okay, so now we want to talk a little bit further. Given that you're trying to tell the compiler what you believe is actually the case, right? For example, the blue one over here, this one will be okay. It will just work. However, sometimes when you got a very large collection to keep track of the dynamic type, which is kind of difficult to really difficult to do, in that case you might be wrong. In which case you're going to run into runtime assertion error. Let's see exactly how this can occur. So we get b.get, let's say 수영 over here. So what this will return dynamically will just be over here 416. Well, this string over here, right? Is really going to return a string rather than a dates. But now you're trying to cast that into the dates. Okay. So this will be more like still a downward casting, right? Because you're trying to cast from any the static type into the string. So as far as the compilation is concerned, this is no problem. However, are we going to run into runtime assertion error? Yes, we are. Because now, let me just say very briefly, we also spoke about this already previously. So now think about this over here. Okay, think about. So now it's a downward casting. Downward cast. But the dynamic type that's going to return is going to return this particular object. Dynamic type, which is a string, cannot fulfill the expectations on the cast type, which is dates. Okay, the consequence of this is going to be violation at runtime. At the runtime. Okay, so you can think about this particular attached syntax over here is going to be a Boolean expression, as we said before. So this one is going to return to you false. Okay, it's going to be false over here, right? That's why the check assertion will actually be violated. All right, so the main message from this illustration over here is when you're doing a cast, you better know what you're doing. If you're doing the right, if you are guessing, well, not really guessing, if you are somehow really presenting the right dynamic type to be cast into, in that case, you will be okay. However, when your application gets more complicated, in that case, if you simply get something, some expression whose dynamic type is not really cannot really fulfill the cast type you want to really cast into, in that case, you will run into runtime assertion error. So you want to be careful. So now it seems like maybe typecasting is somehow like a risky thing to do in general. So we really want to avoid casting as much as possible. So that's why we want to criticize on this particular design of a general book where we simply got an array of any. We want to criticize on this in the next slide. Okay, let's go back to the presentation. Okay, so we already spoke about these two observations. So this is why we got the compilation error from the previous example. And this part here is just about the two possible casts. One is going to be okay, but the other one is going to have violation at the runtime. Okay, so now let's speak about pros and cons. The biggest advantage for this design of a general book is you can store anything into the book. Let's just recall very quickly the declaration for the records array. You can see the static type for the every member in the records is simply just any. So that means accordingly, when you define this command for adding or for storing any record into the book, you can see this simply just any. So that means any arguments who's the descendant class of any will be acceptable. And we know that every class is really a descendant class of any. So you can store anything into the book. So the flexibility about storage is really the biggest pro for this first design of a general book. But let's now see its disadvantage as well. Okay, let me just go back to the slides. Okay, so now everything seems to work if we try to use the attach check, just like the instance of check in Java. And also we try to use the typecasting syntax. Everything seems to work. However, do you see any potential problem? Let me give you hints. We talk about the storage is the big plus for this particular design for the general book. But what about retrieval? When you want to retrieve something from the book, especially the get query that we just illustrated, right? Okay, so now the hints would be, number one, think about extensibility and maintainability, especially extensibility. Extensibility simply means what if your application actually grows over time? Let's say we still got the same book application, but rather than just storing string and also birthday, we might be storing accounts. We might also be able to store maybe house, maybe tree, and etc. Any class that's actually a descending class of any will be able to be stored into the book, right? So now let's think about over time. If you got so many kinds of records that's stored in the book, would that make the retrieval extra hard? That's the question. Okay, so now That's exactly what I just meant. So what happens if you have a large number of records of distinct dynamic types? You got dates, string, person, account, array, container, dictionary, etc. Okay. So now all classes are simply descendants of any, so they are all storable into the collection. Okay, so now let's illustrate the disadvantage by considering retrieval. Let's consider some very general case. Let's say we got 100, or simply just n, distinct record objects into the book that we want to store. Okay, let's say we got C1. Okay, imagine that we got C1 up to C100. We got 100 different classes that we actually have defined. And then we simply declare record 1 to be of static type C1, and also record type record 100 to be of static type C100, and etc. We got 100 objects to be stored into the book. And then we simply create record 1 to be dynamically C1, and also record 100 to be dynamically of type C100. And then we should add them all into the book, basically, right? And we know from the previous illustration, these will all be valid additions because the static type for the parameter over here is simply just any. And C1 up to C100 are simply descending classes of any class. So this will be all valid. So imagine that we got a polymorphic collection of 100 elements inside, but every element that's stored in the polymorphic collection is of different dynamic type. Okay, I don't need to draw the diagram. You can imagine that from our previous visualization. Okay, so now, okay, exactly what I meant. And then every time you retrieve a record from the book, so now what do we do? So let's say if we call the get query of the book, what will be the static type for the query of the return value? Well, it's simply just any. So that means we wouldn't be able to know whether the return value dynamically is actually a C1, C2, C3, or a C100, and etc. We wouldn't know unless we try some instance of check ourselves. So that means you will have to do things like this. You want to say if b.get Jim, let's say we don't really know what the original record we store into Jim, what's really its dynamic type. It could be string, can be dates, can be account, can be tree, can be anything. Let's say we don't know. In that case, the only way we can find out is by saying b.get Jim, and then try to see whether it can be attached or instance of a C1 object. Can it fulfill C1's expectation? If it can, introduce a new alias called C1 of that particular cast type as a static type. And then we do similarly from C2 to C99. And then finally we say if there's a C100, in that case we'll try to call some specific feature. So now we're assuming that F1 is a feature that's only unique to C1. So that's why only after a cast for C1 into C1, we can actually call this particular feature. Similarly, we're assuming that F100 is only a feature that's specific to the static type C100. So that's why only after a cast into C100 can we actually call F100. Okay, so that's kind of the general scenario. So now, is this problematic? Well, so now, do you see some resemblance to some example that we talked about previously? You want to pause the video and think about it? Okay, so a previous design that has a resemblance to this is, remember the second attempt that we did for the without inheritance. Remember we have a student class, only a single student class with the attribute kind, which can be either 1 or 2. And then, accordingly, every command or query that has to distinguish between the types of students, we have to get an exhaustive list of the if statement. In which case, it will violate the single choice principle, right? The same arguments over here. Okay, if you're a little bit unsure about the example I'm talking about, go to the second attempt in the previous lecture about inheritance for code reuse. It's quite important because such violation occurs quite often. You want to avoid that in your design, really. Okay, let me just illustrate very quickly about this violation here, and then we have to move on to the ultimate solution. Okay, as we said before, we got C1 up to C100. Dynamically, it can be C1 up to C100. So now for the retrieval, so this is really the disadvantage for this design. Okay, so this will be the disadvantage. So we're going to violate single choice principle because you see lots of duplicates. The duplicate goes like this. We have to repeat such exhaustive check about what we can cast into, in this case, right? Like what the instance of for the object is. In that case, we also got to repeat this one here, again, for every scenario where we want to distinguish between the dynamic types of the object. So you can see repetition. In that case, so you can think about over here, this is a repetition of checks structure. So this will be a violation of single choice principle. Let me show you two example violation. Scenario number one. What if a new type C101 is introduced? Well, in that case, that means let's say we only got these two routines or queries or commands actually defined. So now, how can we make sure we can also cover this type? We need to repeat the structure over here. We're going to say else if, for example, we're going to say else if attached. And then C101, and then etc. Right? You can repeat. You can finish the rest. And is this the only place? Not really. We also need to repeat over here. We're going to say else if over here attached, repeating basically the same if check instance of check over here. And then we want to do maybe something else, right? So now this is really a violation of the single choice principle because you have to repeating the same thing in multiple places in order to make the change, not really just a minimal number of places. So you want to avoid that. So this is the number one. So it's a violation of the single choice principle. Okay, what about the second one? The second one over there, what if a type C100 becomes obsolete? So that's also like a change, right? So in that case, so that means whatever coverage that we had before for C100 is no longer applicable. So we should really delete it. So this for sure is going to be deleted from this particular routine, but is this the only place that we have to delete? Not really, because you also got 100 over here. So that's the second place you have to delete. If this if statement structure is used in maybe 100 different routines in your design, in that case you have to delete 100 times, multiple places. So this is the second scenario where the single choice principle is violated. Okay, so that's about the pros and cons about the general book. If you simply got a records of any, which makes the storage very generous, you can store anything into the collection. However, it makes the retrieval additionally hard, especially you got to do lots of casting and also lots of if statements checks, which violates single choice principle, and also it's really likely for you to really run into the runtime assertion check for cast exception if you didn't really do the cast appropriately. Okay, so study these details properly, and before you move on to the next video, and we'll talk about the ultimate solution using generics.